All right, we are live on Facebook and we are recording. I'm Dr. John Mercer, and we are doing a video podcast with Jon Thornham from Flo Cycling. And we're doing this video presentation, video conversation in large part because of a graduate class, an undergraduate class I teach on biomechanics of endurance performance at the University of Nevada, Las Vegas. But then also this is for our community members, and our Las Vegas Triathlon Club is following along on stream. And then this is also for our sports science initiative that we're starting at University of Nevada, Las Vegas, where we are focusing on building stronger relationships with industry partners and academics. So lots of reasons why we're doing this, which is sort of fun. And I'm going to give a shout out to Ted Gerard, who's also on this call, and he is co-hosting this conversation. Ted and I have been working with Flo Cycling over the past couple years on a project which admittedly I thought would only take us a weekend to do, and it literally took us about 2 years to get to a point where we were probably still scratching the surface of the knowledge that we were gaining from the test. But Flo Cycling has been an important company to the cycling world as well as the triathlon world. They have been innovators in cycling wheels, and as well as other supporting products of cycling. And they've developed a neat business model that really relies on the science behind developing a product. And I've always enjoyed looking at the material that they generate in when they start developing a product, and we'll get into some of those details here. So I'm going to introduce Jon Thornham, and I got to find your video, John, to make sure that I pin you here. He is owner and CEO of Flo Wheels, and he's been gracious enough to allow us some time to chat with him about Flo Wheels and what he's created, and maybe some of the ideas of where he's going with the company. So welcome, John.
Hey, thanks for having me. I really appreciate being here, and I'm looking forward to chatting today.
Great. Well, let's start with maybe just a little background. I gave a little bit of context of Flo Cycling, but maybe walk us through the creation of Flo Cycling and where the company is right now.
Yeah, back in 2009, I have an identical twin brother, and he was starting to get involved in triathlon. He actually had a short stint where he was doing some work with the Las Vegas Tri Club, ironically. And both of us are mechanical engineers, and we were working for a company, and he started looking at all the products and gear that triathletes look at, and he had bought a bike, and he started to look at race wheels. And at the time, there were two types of brands. Number one, you had a brand that was going through traditional retail, and you would get a price range anywhere from kind of $2,500 and up for a set of wheels. And then there were some consumer direct brands, but they were basically selling a product that was open market or open mold, which basically means that if you went over to a factory that produces wheels, you can go over, they have molds that sit there, and you just say, I want 100 of those. You put your sticker on them, and you have a wheel company. The two main differences between those companies are that the open mold businesses, they weren't really doing any research or design. It was just based on whatever wheels were available. The retail brands were doing a lot of engineering at the time to develop some stuff that was really fast. So this would have been 2009. My brother was getting into this. He came to me, and we started talking about the idea. And he asked me what I thought the wheels that he had just bought cost. And I said $500, which after he told me what they really cost, I almost fell out of my chair. And then he said, do you think we could start a business doing this? And I said, yes. And he said, do you want to? I said, sure. And then the next question I asked him was, what are all the components of the wheel called? I didn't know. And that kind of started a journey. I mean, by the time our first sale happened, it was February 21st of 2012. So it was about a 2.5-year journey to get there, which was filled with a bunch of surprises and things we had never really thought we would, uncover, but definitely worth the journey. It was a lot of fun.
So when you did that, when you started the idea, 2009, and then your first sale in 2012, you said,
Yeah.
were you still in the undergrad program, or had you finished at this point?
Yeah, so both of us were working as mechanical engineers. So we both graduated in May of 2000 or April of 2006 from a school in Canada called the University of New Brunswick. Chris and I are both
Oh,
Canadians.
all right.
And yeah, so we got out and we had these engineer desk jobs that
Oh,
we both absolutely hated. I mean, the kind of the reason I've always kind of gravitated towards designing products from a sports perspective. We had a project actually my senior design project um, in university was it was a machine that was casting a fly rod by itself for fly fishing. It was kind of cool. And I actually had started that project in high school, ironically, and went on to be quite successful with that. And then it continued. So I've always loved the idea of sort of looking at things and developing cool products. And so that's really how this started.
yeah, you had told me that story about the fly casting
Yep.
idea. Can you just tell a little bit more about it? Because that was that's really amazing.
Yeah. So I was actually in the 11th grade, and I was in it was a physics class, and my teacher came to us and said, "Hey, look, one of the things we need you guys to do is we need you to present on the physics of a sporting thing." And at the time, I was doing a lot of fishing. I love fly fishing growing up. I did a lot of it. And so I said, "Hey, I'll do the physics of fly fishing." And so I went into the library, and at the time, I mean, there wasn't a ton of. I mean, I did research on the internet. There wasn't a ton back then, but what I found was that there really wasn't anything that had been produced on the physics of fly fishing. So I went back to my teacher and said, "Hey, look, I want to do this, but there's no books. Nobody's really researched this in any way." And she said, "Well, you got two choices. You can pick another topic, or you can figure it out on your own." So I was like, "All right, well, challenge accepted." So I ended up going out in front of my house. I had a fly rod. I started timing things. I started looking at, line velocities, rod velocities, and I presented it. And she said, "Hey, I really think that you could do well in the science fair with this." And I was like, "Well, I'm not a science fair guy. It's not really my thing." And she goes, "The scholarship money." And I said, "Well, sign me up," because I was paying for my own education. And at that time, I talked to my brother, and he got involved, and I ended up building this uh, machine. So we did some pretty cool stuff. We took photography and video back then, which was more challenging than it is now, and we determined the casting angles of a human arm, and then I built this machine that would basically cast the fly rod by itself. And we were casting about 50 feet of line. When it first started, we had massive issues. It would throw the line, and traditionally, if anybody's ever who has not fly fished, when you throw the line, it goes out. The line kind of goes stationary, and then it drops to the water. When we were casting it, it was vibrating like crazy, and I couldn't figure it out. And I was sitting there one day, and I was just watching my brother cast, and I recognized that at the end of the cast, his wrist was just moving slightly to basically dampen the rod motion. And so I said, I think we need to put in a mechanical wrist. And so I got this spring and developed a mechanical wrist. And after that, I mean, this thing would cast 50 feet of line. It would go out, and it would just fall to the ground. I mean, it was really, really cool. So we hired a strobe photographer, and using strobe photography back then, you didn't have to like easy slow motion cameras with phones. And so we were able to graph and velocities. And so I took it to the regional science fair. We won that, which got us a ticket to the Canadian National Science Fair. And we placed third in the country for engineering, which was actually kind of a fun process. I mean, I never thought I would go down that road, but yeah, that's how it worked. And by the time I got to university, we had kind of figured out a way where we could use it was a cam and rocker system basically. And so there's this giant book that's filled with different patterns, and so we found them that matched, and so we were able to basically design it with a motor where it would just continually move back and forth and cast the line. So it was fun.
So
It was really cool.
that is so cool. So you don't still have it, do you?
You know what? I had a scale model of it that I built years
Oh,
ago. And I don't know why I did. I just wanted one. I think I had it in my room for a long time. But that thing actually sat. It might still be at my parents' place. I don't know. If it was, it would be pretty cool
yeah.
to still see it, but it was a pretty cool project.
So
Well,
John, this is Ted. I have to ask, being as I'm a Canadian as well, were the two people that beat you, did it have anything to do with like beer drinking and hockey, or?
No, man, it didn't. It's
Because like I can see fly fishing right up there with those two things. Being a Canadian.
yeah, for sure. I think that one of the ones that came second was a mission to Mars. They were trying to figure out how to go to Mars, and the one that like won and it won the whole thing was, I don't know what this kid did, but it's called sonoluminescence. So he had this glass ball, and he would inject a bubble into the glass ball, and he had speakers on the ball that he would vibrate it to basically trap the air bubble in the center of this glass ball. And then he would change the frequency of the speakers, and the bubble would collapse on itself and produce light.
Oh, wow.
Yeah. And so he basically developed a system to repeatedly show something called sonoluminescence. And like, he was the poster child of the whole fair. So he beat us. Hey, that's cool. I built a little machine that cast a fly rod. This kid was like changing his understanding of physics. So yeah,
but now you're the owner of a very successful wheel company, and he's probably messing around with speakers somewhere.
Yeah, that's cool. Happy, right?
Well, what I really liked about that story when you told me is, one, it highlights your innovation, your entrepreneur type of approach, but then also the teaching that you had a great experience with someone allowing you the opportunity to explore and apply some skills in a very unique way.
Yeah, Miss Reagan, I think her name was. Yeah.
So now jump forward to 2009, and I know you said your brother was looking at the wheels first, but how did you say, oh, we want to do something with wheels? I mean, we buy things all the time, and we don't sit around and say, oh, let's start a company to build this better. I mean, what was it about the wheel that was actually attractive that you said, oh, here's an opportunity?
Oh, that's a great question. I don't think I've ever been asked that before. I think what it was there was probably a lot of naivety on my behalf. I think if I would have known everything I know now before I got into this, I probably would have thought I was nuts. I still do think what we did at some points was a little naive. The original idea was for us to make something as affordable as possible, but make it fast. And the original wheels were going to have plastic fairings as opposed to carbon fiber fairings. And I think what it was I saw an opportunity. I saw something that didn't exist. Something that I felt like we could make an improvement. And I've always been, ever since I've been as little as I can remember, I always wanted to own my own business. I've always had a very entrepreneurial mind. And to me, this just felt interesting because it was sports related. I'm very active. I love sports. I love those types of things. And there was an engineering part of it that was super cool. And, it was business related. So I think, I think it was just a combination of all of those elements for me that really said, this is cool. You could probably do this. And so I think that's probably what it was,
Well, I want to get to the engineering part, but I've also really been impressed with your business approach with Flo Wheels. I mean, you did not just try to do what another wheel company was doing. I mean, you've been very open with people about research data, but also your business model of doing orders ahead of time and then batch processing them. I mean, where did you get your business acumen, your experience to build it this way?
I don't know, to be honest. My father is a sales guy his whole life, and I've watched him sell. My grandfather was in sales, but as far as a pure entrepreneurial spirit in my family, I know of I'm going to pull this down. It's kind of a cool story. This here this sits in my office. It's a fish label. So it's like my great grandfather owned a fish plant canning company in the middle of nowhere in Nova Scotia. Was very successful, canned for the Carnation brand. And shortly after he died, he had a daughter who took all of his money and moved to Beverly Hills. And she lived there until she died, probably in the 70s. I mean, I just knew the story. So I'm guessing somewhere back there that there's some entrepreneurial spirit in the family. I've never personally met them. It's just something that I've always kind of been driven to. I had started a business with my brother prior to this, and it did not work out. And I think what I learned in that process was I had no idea how to market. I had no idea how to attract an audience. I had no idea how to even discuss a product, build a list, anything like that. So I read, I don't know how many books I read. I probably read 2 dozen books just to understand marketing. I got heavily involved in reading legal books. I got heavily involved in reading intellectual property law. I got heavily involved in reading pretty much anything I could get my hands on when it came to around business. I was obsessed with learning about finance and bookkeeping and anything that was entrepreneurial. I loved it. It was just something that I really wanted to learn and understand. And I think the fact that the first business didn't work, I think was probably one of the best lessons for me. I think I really realized that I love this. I love the idea of this, but it's like tuition, I mean, we spent a decent chunk of money on something that I never got it back, but I think it taught me some pretty valuable lessons. And so I think my drive as a young kid to want to have something and then just kind of learning the hard way set us up for this business where I said, okay, I feel like I have a lot of the tools that I need. And we were kind of at the time doing things in ways that weren't really created. Our first order, as you pointed out, we kind of built this hype around it, and we started the first order, and we crashed the web server as soon as it went off. We luckily got it back up, and within an hour, I mean, we had sold more products than, it would have equated to probably 4 years of salary for me in the first hour, which was something that was really cool. And this was before the time of Kickstarter. Kickstarter didn't exist. A lot of those programs didn't exist. And it was just, I was trying to figure out ways to do things that were unique. And back then, the internet, from a marketing perspective, is not what it is today. I mean, there were really no ad dollars, or there was really nobody writing or putting content out like there is today. And so we kind of capitalized on this opportunity where, from an engineering perspective, most companies at the time were really quiet about everything that they did from an engineering perspective. And we said, well, we're going to tell everybody everything that we do. We're going to take them along on the ride. And it created sort of this, community feel. And I think it was a big part of why we were able to do what we did.
Oh, that's great. And yeah, it's really, really neat to see that develop. But at the same time, you've also been very strong at giving back to the community. And I'm thinking of your Build a Bike, and I think you've got a tree initiative as well. How did you get involved with Build a Bike, and maybe tell people what that's all about?
Yeah. So our Bike for a Kid program is something that I've always been one to try and give back to the community in some way. Even from as a young kid, we had a special education classroom in the middle school. I would just go in and volunteer in lunch and recess, and I learned so much, doing that. It was a fascinating experience. I've always been involved in education to some extent. I was in, I taught multiple different sports, instructed in a number of different things. And so, and now, I mean, one of the things I do now is, well, not now with this pandemic, unfortunately, but I have a dog that's trained as a therapy dog that we go into nursing homes and kind of give back to the community. So I've always been sort of community-based. I'm also a believer of trying to, give opportunities where people have, you're giving them something to create an opportunity. And so what we thought about was, when we were starting this business, I was talking to my brother. I said, look, I really want to do something that we give back. So yes, we're going to take from this community in a way where, yes, they're going to buy stuff from us. We're going to provide them a product, but what can we do that creates positivity and change? And so the idea came about, well, everybody is buying products from a wheel perspective because they love to ride bikes. There's a joy of riding a bike that anyone that rides one that is kind of undeniable. I mean, I remember first riding a bike when I was a kid. That was my freedom. That was the thing that allowed me to just get out. And though my mom only really let me ride in front of her house, I felt like, I was on my own mission to get out and go do whatever I wanted. And what we realized is there's a lot of kids that don't have bicycles, especially younger kids in certain areas. And so we developed this program called Bike for a Kid, where 1% of all of our sales go back to buying bikes and helmets for kids in need. And it just started kind of humbly, like, we worked with a couple partners, and, we would go out to these areas and we would give these bicycles to these kids. And, it's amazing what you see. You go there, and I think for most of us, it's kind of, you learn to ride a bike when you're little, and you don't think about it. But we built these bikes for these kids, and they come over and say, hey, they're so thankful. Most of them are always just so grateful. And they say, can you teach me how to ride it? You spend 5-10 minutes with a kid teaching them how to ride a bike, and it's amazing. The program has expanded, which I've always said I love selling products and I love designing products, but when you do this stuff, it kind of reminds you of what there's more to it, what the purpose is. And in 2018, we started a partnership with the Ironman Foundation, which is the charitable sort of side of Ironman. It was originally with a guy named Dave Deschaines, who I'd known for years, just an incredible individual. Love that guy. It's now been taken over by a great woman by the name of Sarah Hartman, who is just really helped us expand this program. And they have become a huge supporter of what we do. We're getting other brands involved. So it's not just our money going in now. There's money coming in from all over the place. And what we do is we activate in certain communities in need. So around specific Ironman events, we go out and we set up in the expo, and we have athletes come out, we have community members come out, and we build bikes for these kids, and then we take them and we drop them off. And we've just been blessed. We've been able to work with groups like the CMAC Foundation, which is started by a mother of one of the victims of the Sandy Hook shooting. And it was, I've done so many of these events, and most of them you get kind of choked up, but that's one that stands out in my mind. That it was just, to see what you're able to do with it is it's amazing. It's one of the best things about this business, that I've always been so grateful to have the opportunity to do it. And then I would say probably in 2015, 16 maybe, I've always been probably somewhat of a nature guy. I love environmental stuff. I'm always about that. And I wanted to also create products in some way that are trying to take care of the planet that we live on. I think that unfortunately, a lot of times businesses can look at it in a way where, we're just taking from, we're not doing anything to give back. Unfortunately, cycling wheels, in some ways, we use as many recycled materials as we can. We try to recycle. Carbon fiber is a very difficult product to recycle. But I sort of came up with this idea back then about what can we do that will help offset carbon footprint. And so the first thing we did was we decided to create a program called One Wheel, One Tree. So for each wheel that we ship, we have a partnership with a group called American Forest, where we plant a tree, and that tree easily offsets the carbon footprint of that wheel throughout its lifetime. And the other thing that we have done is all of our boxes and everything are made of 100% recycled cardboard. I actually designed a box to remove all plastics. So, which is kind of an interesting thing. I mean, most wheels ship with a ton of plastic in there. One of the things you have to protect is the hub. So we designed this thing where there's a cardboard insert, and it's kind of cool. So, none of our products now are really affecting the environment more than from a carbon footprint perspective. We're actually giving back more than we take. And so I don't know, it's just something I'm proud of. Like I said, I love the development of that, but to have a sustainable, responsible company, I'm really all about. So it's pretty cool.
No, that's great. And, I've always seen the bike building that you do with the kids, or for the kids at the Ironman races. And I love that, because that gives the athletes a chance to participate in something like that.
Yeah.
And maybe they take something back to their community, and it sort of grows out of that. So I think that's neat that you involve the athletes that way. And I didn't know about your box. I'll have to go, have to look at your box the next time. That sounds pretty cool.
Yeah, it's kind of cool. It's the only one out there that is built like that. I mean, traditionally, if you look at wheel boxes, I've seen them from pretty much every vendor, every maker. It's the same thing. It's the same wheel box, and ours is this kind of unique design that allows us to remove the plastic. So it's
All right, so let's get into the science of wheels. So you
Do it.
do CFD testing, you do wind tunnel testing, you've built devices that you put on bikes to figure out which way the wind's blowing on different courses.
Yep.
The work that we did with you, and thank you for including us. We're measuring drag force and rolling resistance. Which
Yep.
is your favorite engineering area to get into when you start doing wheel design?
That's a good question. I think my favorite thing about just engineering in general is trying to look at a problem in a unique way.
Hmm.
And if I can get excited about whatever it is, if it's rolling resistance, if it's aerodynamics, if it's a box, like I was just talking about the box, what I love is the ability to be able to sort of go off on my own, think differently, and think in a way that I know that if I keep pushing in that direction, we could create something that's really cool, really unique. And I think that's why I love engineering. I remember when I was in school for engineering, by the end of it, I was like, I hated it. I actually had this T-shirt printed and it said "engineering sucks" on it, right? And it was a joke for me. I would kind of wear it around. And it was weird because I went to engineering because I developed this fly fishing thing. I was like, this is cool. This is exactly what I want to do. By the end of it, I got out, I had this job. I was reading spec books and I'm like, this is pointless. And then as soon as I got back into working on this business, I was like, this is exactly why I went to school in the first place, right? It made me remember exactly why I was doing what I was doing. And like I say, if it's a fly fishing machine, if it's whatever, if there's a cool, unique way to look at it, that's my favorite part of engineering. And that's my favorite way of designing a wheel, is to look at it in ways that are unique. And I think for the way that and I'll tell kind of the overview of kind of the history of how we've designed wheels, which is somewhat of a unique process. Is most wheels when we first started were designed in wind tunnels. And so the way that would be done is companies would develop a number of different rim shapes, maybe 10 or 12, and they would take them to the wind tunnel. And wind tunnel time is extremely expensive. I mean, you're probably in the order of, you know, $600 to $1,100 per hour. And for a young startup, we did not have that kind of money. So we started looking at ways of how can we do this. And so we developed CAD models and we put them through something called computational fluid dynamics software. Fortunately for me, I had a buddy who I would call on in the engineering space, and they had a license of this extremely expensive software. And he was the only guy in his office who knew how to use it. He was my age. He worked for a bunch of these guys that were they didn't even know what they had. And he said, look, man, if you ever want me to use it, he goes, I'll just let it run on our computer. They won't even know it's running. And I said, okay. So he ran 28 days of model processing for us for a set of wheels for his uncle when we were done. And if we wouldn't have had that opportunity, there's no way it would have happened. But we developed this rim shape on a very limited budget that was extremely fast. I knew from the beginning the way that I wanted to tackle the problem. And our second generation of wheels was developed with a lot better, a lot smarter approach. So the first thing that we really wanted to understand was, what does a cyclist actually see? What do they actually experience when they're on the road? So, this is a current rim profile. So this is like a cycling rim, and this is the profile. It's kind of cut in half, so you can see what that looks like. Back in the day, most profiles were just sort of like a V shape. So the idea was that the deeper it gets, the better, And because if it was deep, that made it fast, but there were a whole number of different issues with that. So what we did was we said, if we can study and understand what actually happens to the cyclist on the bike, then we can design around the wheel and in the wind interaction that they see. So there's a famous graph in the cycling wheels. It's called the yaw, which is basically the angle that the wind hits you, and then the drag graph. And so guys would design wheels and they would find this low spot and say, oh, look, our wheels are this fast. And my mindset from the beginning was that doesn't make sense because we don't know what people actually see. So at the time, there wasn't really anything to collect this type of data. So I built this computer, which I actually have it here. It's got a funny nickname
Oh,
now.
there we go. Wow.
This
Look at
thing here
that.
is huge. It was mounted to the front of a bicycle, and basically I built. This is a weather station, which has it's been sitting in my garage, so it's a little bit dusty, but it's it records data every second, and so we bought this super fancy anemometer, which is this thing here, which basically measures your wind speed, which is your relative velocity, and then a weather vane, which this is a very high precision German engineered weather vane that when you mount this on the front of a bicycle, you know exactly what angle the wind is interacting with you in the bicycle, and you know relative velocity. So what relative velocity means really quickly is if I'm riding down the road and I have a tailwind behind me and we're both going 10 miles an hour, my relative velocity at that point is 0 because I'm going 10, the wind's going 10, so I don't experience anything. If I'm riding into a headwind at 10 miles an hour and I'm going 10 miles an hour, my relative velocity, this thing's going like crazy, I'm going 20. If I'm in dead still and I'm going 10, it's 10. So we really wanted to just understand what happened. So we took all of that data and we rode over 4 different Ironman courses all over the different places of the country. We rode through forest areas, we rode in groups, we rode, on the ocean, we rode to see what would happen. And we were able to basically produce this data set that said, this is what cyclists typically see. And the original idea was that the cyclist, from some work that others had done before us, was that 80% of their time was spent between 10 and 20 degrees yaw. And what we realized was that, 80% of your time is really spent kind of within the first 5 degrees of yaw. So it was a massive shift in sort of understanding, not only for us, but I think a lot of the cycling community. And then what we did is, instead of taking and going to the wind tunnel, rim shapes are really designed around aerodynamics. And there's no equation that says what makes something fast. You have to test. That's why wind tunnels are designed. NASA, you look at all the, Boeing and all these different huge wind tunnels, they just test and test and test and test to figure out what works. So the more time you test, the more prototypes you have to make, which is expensive. The more time you need in the wind tunnels, extremely expensive. And my idea was, well, we don't want to do that. We want to do this in software. So we created an algorithm. It's an optimization algorithm where we gave the computer model a set of parameters and said, you can move anywhere in here you want, but your job is to solve for something that's fast. And so it allowed us to test over 500 rim shapes, which at the time was unheard of. Not only we actually put it on the supercomputer at the time. It was like 64 cores. It was at the CFD, center. And that took something on the order of, I think it was 2 months to process on a 64 core computer, which was unbelievable. I mean, if it would have been on our original computers, I think it would have taken like 4.5 years to compute.
Was anyone getting worried and this program's just hanging? Or you were?
No, I mean, it runs nonstop, right? That's how long it takes. I mean, it was fascinating to see. And these results came back and we're like, okay, well, this is cool. And we took them we go to the wind tunnel after because we want to verify it's real world. We designed with just rim shapes. And some people have argued with this over the years, but it's a general approach where we don't model hubs and spokes in there because our opinion is that, number one, the modeling of that is so complex that you're kind of missing the point of, you're trying to optimize a rim shape and you're trying to optimize it. Back then it was just the rim shape around a specific tire. And we'll talk more about what we've done, I'm sure, later on the new stuff. But back then we were able to increase the speed of our wheels by about 23%, which they were already fast. And in aerodynamics, you're really looking at like a 2 to 3% gain is huge. But because of that algorithm that we developed in that data, it allowed us to do some really cool stuff. And had never been done before. It was that's what I mean. That we looked at the problem in a way that was completely unique. And that's what I loved about it.
Oh, that's amazing. I didn't know it was that big of a jump, but I saw pictures of the device that you built and saw you riding with it. I mean, that's really amazing. So now, just curious, because I know we've talked about best bike splits in the past, and they used the wind direction. Did you share some of those data with them to help build their algorithm?
Brian Cooper is a good buddy of mine, and he is top 5 most brilliant people I've probably ever met. the fact that he's in cycling is a benefit to everybody in the cycling industry. And he is, his original sort of claim to fame story was he was a PhD student in mathematics, and he was a cyclist, and he was watching the tour, and he heard the Trek team was using computer models to kind of come up with an understanding of how the guys should ride over the course, how much power they should put out certain sections. And they were doing some like data calculation and certain things like that. And the big issue that they had at the time was that the models were taking 7.5 hours to compute. And Ryan went to his PhD guy and was talking to him and basically said, hey, I'm interested in this. And he goes, well, so let's just see what you can come up with. So he developed a model, and it was more accurate than the Trek team model. And his would compute and process in 3 seconds versus 7.5 hours. And so instantly Ryan he's pretty much worked with every tour team that's existed. He developed something called Best Bike Split, which he then sold to a company called Training Peaks. And his knowledge and just the way he thinks about problems, he's a machine learning guy. He's just brilliant. He's a mathematician. One of those, like I say, one of the most, if you want to talk about solving a problem in a unique way, Ryan is one of those guys you want in your phone. He's a guy that I call to kind of shoot through things at times. If I have questions, he's just a great guy all around, and he's a brilliant guy. So,
that's great.
That's right.
So, yeah, and I'm gonna tap into that a little bit in a bit, but on your wheel design,
yep,
you ran this program where the big O is, a long time, but it's not all. Wheel design can't be all about aerodynamics. You got to have strength in there too. So how did you account for strength, or is that just naturally part of the design when you are focusing on aerodynamics? Even the side-to-side flex of the wheel. I mean, does that come into play?
It does. I mean, it does. So really, aerodynamics is based on, how is the air or wind interacting with the object, the body that's exposed into the air fluid, right? I mean, that's really what we're looking at. And structurally, I mean, if you look inside this room, so we originally started with a product that was, and this is before carbon fiber was as successful as it is now. We developed a rim that had a wheel that had an aluminum rim and a carbon fiber fairing, right? So fairing meaning that the spokes actually pass through and they connect up here at the rim. So the carbon it had no structure. I mean, it didn't matter. It was just there to basically deflect air and make it more aerodynamic. Aluminum rims are pretty at the time we did it, and now, I mean, you can't really mess with an aluminum rim if you have a good manufacturer. So we really sourced great manufacturers, great factories out of sort of the world's best, which is companies out of Taiwan. And so we, early in our careers, we went to Taiwan and sourced factories. And actually we started in China, which was an absolute nightmare. We lost a bunch of money on molds. We were actually supposed to start selling in 2011. And we got a call from the factory we were working with about a month before we were supposed to start selling, and or less than that actually. And they said, we're waiting for your engineers to come over and teach us how to make cycling wheels. We had opened molds, we had received prototypes, and there were so many issues. I mean, that's a whole nother story. But my brother actually, because we didn't have any money at the time, he hopped on a plane, went over, beat his way through Taiwan, and found who I would consider is probably, top 3 rim producers in the world. And he convinced them to give us a shot. We were nobody. We had very limited money, and he did a great job, and those guys are experts at carbon layup, mold layups, understanding structure. They've made millions and millions of rims. And so we rely a lot on the expertise of great factories. Have I ever looked at carbon layups? Have I ever discussed them? Have I ever worked on projects where we are looking at layups? Of course, I have. I've looked at some of that stuff. I understand carbon fiber quite well. But when you're talking about making millions and millions of products, and you're looking at people who have done that, and you look at cost efficiencies and certain things like that, we do rely on that. So you look at this rim here. This is one of our newest rims that was actually done with a lot of the work that you guys helped us with. Is you can see, it's kind of hard to see, but you can see very different widths and thicknesses inside the rim, which is all based on structural things, and that's how it supports itself. It supports itself, from a roundness perspective, from a torsional perspective, from a stiffness perspective, and then a lot of it goes into the actual wheel build. Who's lacing it? What's the lacing pattern? What spokes are you using? So yeah, that stuff is all considered in there as well. But it's kind of an afterthought to some extent.
So, John, other than strength and aerodynamics, what else makes a good bike wheel, like a fast bike wheel? I think this will be a segue into what maybe some of the projects we worked on, because there's obviously a lot of other factors. When you started out, aerodynamics was pretty much everything, and I think we've kind of turned a corner recently in that. So if you want to expand on that.
So the joke internally was my brother and I left the wind tunnel on I think it was December 1st of 2015, and I looked at him and said, how on earth what do we do next? How do we make a faster wheel? I was perplexed. I really didn't know what we were going to do, because we just built this computer. We had built this optimization algorithm, and well, how do you make it any faster? Do I put it through the optimization algorithm again and get the same answer? And I was really perplexed. Ironically, at that time, we had done an aerodynamic study in the wind tunnel, which was this giant tire study. It's kind of we tested like pretty much every road tire at the time, just to understand the aerodynamic perspective. And there's a guy in the industry, his name is Tom Anhall, brilliant guy, another one of those guys that you need to know in this industry if you're going to do anything. And he was starting this blog. He had something called Blather About Bikes. He was starting to look at rolling resistance, which rolling resistance is basically the amount of watts that it takes you to move a bike forward. And tires specifically, some tires are really, really efficient when it comes to rolling resistance, and some are just complete pigs. I mean, they're like horrible to roll with. And so he said, hey, I really like your data on the aerodynamics. And he said, we could merge these two things together. You could send me all the tires. We could then take a look at, the number of watts that are consumed from rolling resistance, and we could add it to your aerodynamic data, and we could see which was faster as a system. And I was like, well, that's cool. Let's see what it does. And I, completely ignorant on my behalf, I'm thinking, oh, we'll see what this does. Well, the drastic difference that we saw from a rolling resistance perspective absolutely blew my mind. I was floored. And we took, aerodynamically, a thinner, smaller tire. So tires come in different sizes. And it's the same model. It's just a bit wider. And historically, thinner is better. It makes sense. It moves through the air better. And so we were realizing that tires of much larger sizes of the same model, when you combine both rolling resistance and aerodynamics, were faster. So then at that time, I said, the way we're going to make wheels faster now is we've only been looking at half of the equation. We've only been looking at the aerodynamic component. Well, to make a wheel fast, we also have to consider rolling resistance. And at the time, tires were just starting to work on that, but nobody had really said, can we make a wheel improve your rolling resistance? Now, there was some speculation around, wider is better and it changes contact patch. And we had done some work on contact patch, understanding certain things, but nobody had really done anything to sort of get hard empirical data on understanding rolling resistance and rims. There was one group called Silka, which a guy over there, another one of the guys I always love to have around. His name is Josh Portner. He's actually the head engineer of a very successful wheel company. And they did very innovative things all through. He's done innovative things all through his whole career. Great guy. He had bought a pump company, and he was kind of remodeling these pumps. And he started to look at something on-road rolling resistance. And he was actually doing some of the stuff with Tom Anhalt, the guy over there. And they realized that with rolling resistance, typically the higher your pressure, if you're in a lab, like on a steel roller, the lower your rolling resistance gets. And there's a lot of information behind that, but I'll try and make it as simple as possible. Basically, if you think of a big flat section, because you have no air pressure, you get a big flat section, and in order to overcome that, you have to deform the tire a whole bunch, and it takes a bunch of energy to do that. If you have a really, really high air pressure, you're sitting basically on a little small section. There's very little deformation, so there's very little air loss. Well, what these guys had studied was that, yeah, your rolling resistance on rollers goes down as it gets higher, but they were studying rolling resistance on the road, and they realized that at a certain point, which they named the impedance breakpoint, the rolling resistance would drop gradually, and then you would hit a certain pressure where the pressure would be higher than the impedance breakpoint, and the rolling resistance would just shoot right up. It would spike way up. And that was a huge thing to realize, and it just consumed so many watts from the cyclist. And the old belief was that the higher the pressure, the better. The higher the pressure, the better. And so they started telling that story that you need to lower your pressures. And so that's when we said, okay, we had already said we need to figure out, can we design a rim that does this? And so we then went back to our drawing board and said, well, we need a computer that will basically allow us to measure on-road rolling resistance. So that's kind of where the computer that I originally built was something that I could actually develop, but the new computer that we were looking for had not been developed, and it was not something you could kind of piece together from off the shelf parts. And we ended up working with one group, great guy, and it just wasn't really what it was. We were getting data, but the post-processing time for like one single ride was like 4 hours. It was ridiculous, and it was probably mid 2018, I just got this random notification one day saying that there was this group out of Calgary that was determining how to measure on-road rolling, really on-road aerodynamics, something called CDA. But there was a small section there saying that they could also measure rolling resistance. And I was like, who are these guys? So I ended up contacting them. I flew up to Calgary with my wife, and we went in, and I spent 2 days with these guys doing on-road testing. And I kept asking them, look, I really want the rolling resistance. And they're like, well, why are you so concerned about the rolling resistance? Because everyone that they talked to previously was looking for aerodynamics. And I said, well, we're trying to design rims. And so we kind of came up with a base level protocol, which I'm sure John and Ted can talk volumes about our new protocol. And so, yeah, we ended up getting the sensor from them. That would have been in the fall of 2018. And we really completed a lot of our work in February of this year.
Yeah.
But what I personally learned, I think what these guys personally learned, and what we've proven, is that a wider rim, so a wider internal rim width, will actually lower your rolling resistance. And there's a whole list of reasons as to why that's true. A lot of it has to do with something called casing tension. A lot of it has to do with the ability that you're actually able to lower your pressures. It has to do with just the contact patch and how it gets shorter. And what you're doing is you're able to save watts. And we've shown, on average, by widening from our old rim widths, probably in the order of around 5 to 10%, depending on the rim and tire, which is a considerable jump. So then, since we knew that, our old internal rim width on a rim was about 17 millimeters. The new stuff is out to 21, so it's almost a 25% jump. And then we actually developed a gravel series as well, which is for a different type of riding, and that's a 25 millimeter internal rim width. And now that we've done that, we actually did have to re-optimize the rim shapes to go with a much wider external shape. Tires over the last few years had made this massive jump to, say, 23 millimeter tires, which when we designed the previous generation were really wide for the time. Those are now, we didn't even test them this time. They're so narrow at this point that we realized that there's really no use to have a 23 mil tire unless it doesn't fit the bike. And so these wheels, the new stuff, has been optimized around tires starting at 25 all the way up to 32 millimeters. And actually 28 is the fastest that we've determined. So it's a perfect combination of you have a rim that is extremely wide internally and externally, but it still fits bikes. That's the big thing. We're really limited around frame makers and brakes and those things. So we've designed them so that they still fit as wide as they can get, and that a 28 mil tire fits on it extremely efficiently. And we actually designed them around a very specific brand and model of tire, which is just a great tire. We've been able to drastically reduce, again, our time savings. We're talking the order of 1 to 2 watts per wheel, which doesn't sound like a lot, but in the world of cycling, like that's a pretty big deal. So if you consider, an average cyclist, and Ted and John are probably going to answer this better than I am, what do you think the average FTP of a triathlete or road cyclist would be?
275 watts.
275, right?
For
and so
someone that's pretty elite.
Yeah, and so from just changing the internal rim width and redesigning these, we're able to take out roughly 4 watts over our existing wheels, and over a standard wheel that you get on a bike, we're in the order magnitude of 10 or more watts, which when you consider that, it's free speed, it's free it's free improvement,
Yeah, people pay a lot of money for 1 or 2 watts.
They do.
Optimizing a chain gives you 1 or 2 watts. Optimizing pulley wheels, 1 or 2 watts, and they'll spend $500-600 to do that.
Yeah, the smartest athletes, the best athletes. I mean, I've been to a lot of the world championship races, and I've seen a lot of the pros bikes, and the guys who win the bike races, if you look at their bikes, they do not miss a single upgrade or improvement. They are brilliant at what they do. They have brilliant mechanics. Their works of engineering and art, they're great. They really take everything into consideration. There's actually a pro triathlete, great guy. I think this is right around the time we were doing the study. I think it was 2016. And we just learned all of these things about tires. And Kona, where the world championships are held, are known to have some pretty rough roads, a lot of steel radial that comes out of tires, a lot of stuff that can give you flats. And this poor guy, he ended up riding a tire called the Continental Gator Skin, which is bulletproof.
Yeah.
But because he rode that tire, he lost 8 minutes on the bike course just because he rode that tire. And that's something that we realized. And at the time, people really didn't know that. That was kind of new stuff.
He'd have been better off having 2 flats.
He could have had 2 flats. Yeah. He could have done, so many different things with a better tire. He still would have saved up. And I think that year he lost the race by like 6 minutes. Right. So that is it's crazy to think that he probably would have won if he would have just used different tires and he didn't know.
Yeah, I always tell triathletes that sometimes the first place they can start is find good tires, and find good wheels, and then go from there. It's really and especially from the work that we've done with you, which is really, it's been a huge learning curve for me. I mean, and from an athlete, I used to pump up to 120 psi. That was just what I did.
Yeah.
Not anymore. Now we're running 85, maybe 90 psi on the tires, and that's really from the work that you've led.
Well, what you guys have done, to help us is, there's been some other work out there. There's been some things that have been done, but what we've realized, and we've learned some things that have never been published before. The idea of that the faster you're going, the sooner you hit an impedance breakpoint. Yeah. That was undiscovered. Yeah. I've talked about that with a couple of people in the industry, and they're like, never heard of that. It makes sense. And so we've really sort of uncovered these things right now that are really sort of advancing our understanding, not only of wheel design, but just how to make people faster in general. And you guys are a huge contributor to that. I mean, without your guys' help, we would not have been able to accomplish that. So
I really thought it was going to be a weekend project, and it certainly there's a lot more.
I thought maybe a month or two, but
but and it's been neat to see how disc wheels have come around. And I think what disc wheels, and correct me if I'm wrong, but they give you more freedom to build your wheel the way you want to build it versus being more restricted by a frame.
So it's like the catch-22 with disc brake wheels, right? I mean, we've studied disc brake wheels in the wind tunnel, and typically with a rotor on there and everything, just the wheel by itself in the wind tunnel, you're adding 2 watts. with a disc brake on there, right? Now that I understand, we haven't looked at the whole bike, and so there's arguments around that, but generally a disc brake bike is slower because of the big honking rotor and caliper and everything down by the hub. The benefit of it, though, is that you get a lot of clearance and you get a lot of access and ability to move up at the rim because you're not restricted by a brake sitting over top of a rim brake. So yeah, there's some definite benefits there. All the gravel line that we developed that's all disc brake oriented stuff. These gravel wheels that we developed, they're first of their kind, aero optimized and rolling resistance optimized gravel wheel. All gravel wheels you'll see in the market now are very shallow. They don't have any aerodynamic profile. And it's kind of been that thing where you can't really design something aerodynamic with a big knobby gravel tire on the front. And that's unfortunately, that's just not true. I mean, we've been able to save pretty much the same order of magnitude from a watts perspective with a gravel wheel that we do with a road wheel over a standard shallow rim. So we're looking at, again, order of magnitude of 10 to 12 watts over what you would any
That's
gravel
huge.
bike in the world would have right now. So it's a huge difference. And gravel cycling is kind of this hybrid of people that are doing races like the Yuri Kanza. They're 100, 200 miles. Some of them are even 350-mile races. But when you're on a bike for that amount of time, you want every watt advantage that you can get. I mean, it's huge time savings when you're looking at that duration.
So, something I learned was how much the wheel, the tire, and the tube all interact with each other to have that lowest rolling resistance. So who's leading who here? How much do you talk with or work with tire manufacturers, given your wheel design?
Tire manufacturers, a lot of the good ones, like look at Continental. Continental makes some of the best tires in the world. However, Continental, their bicycle market share or percentage of their company is probably 2 to 3%. 97% is automotive. So tire engineers they do great things, but tires are also a very, very funny thing to design and develop. A good friend of mine, Josh Portner, they at one point at Zip were trying to develop this tire with a very successful tire company. And they were basically they just said, hey, can we just repeat the fastest tire that we can find right now? Can we scan it and can we mold it? Develop this tire. And they couldn't do it. They spent, a ridiculous amount of money, and they ended up scrapping the project because tires are there's so many nuances with tires. You're talking about more pressure, it expands more, it's a different shape, the compounds change, the rubber changes. So we're, as wheel designers, we're kind of subject to what we get in a certain way. And some companies have wheel tire combos, but I've never seen one that is faster than just getting the best tire and designing a really good wheel around it.
Oh, that's great. Oh, interesting. All right. So your intuition has always been important in innovating your ideas. But the other part that I see and I know of you is the research part. What I do is work in the lab, and I work with students, and we train students to be negativistic. That is, you're always trying to design an experiment that refutes your idea. That gets it says you're wrong. So where along your path have you had an idea that a research project has forced you to sort of rethink the design?
Wow, I like that question. We're currently working on some stuff right now, which will be our sort of next generation of cycling wheels, which really isn't public knowledge yet. But what I can say is that we're adding something to a cycling wheel, and figuring out how to actually add that through trial and error and experimentation has taken us back to the drawing board more times than I thought we would have needed to. So one thing that I think, and there's one other project, when I was first building that computer that goes on the front of the bicycle, I was actually doing a lot of the development myself with microcontrollers, and I was kind of programming and designing stuff on my own to capture a lot of that data. And I was writing it out to like an SD card, and I thought, hey, I'll just breadboard this thing and put all these circuits together. And that was my introduction to how much vibration a bike has and how much vibration affects a breadboard. I probably went a mile, and I had more, every piece that was in that breadboard was shaking around in the box that I had. So I really had to learn about soldering pretty quickly because I couldn't use a breadboard. But yeah, the newest thing that we're working on right now has been a challenge. It's not been done before, and it's kind of this thing that we've redesigned it many times, and I think we're pretty much at a final design, and I will know probably more hopefully shortly. But it'll be really cool. We're excited about it.
So it's a lot of it's an iterative process in developing a product. You have an idea.
It is everything for me from I've always said, and I say this to our guys all the time, it's like, if we're not breaking something along the way, we're not learning anything. We're not pushing the envelope hard enough. We're either being way too conservative, or we're, I mean, we crash test stuff, we impact test stuff. We want to break stuff. We want to see, how does it perform? How does it do this? And so a lot of times, if you get a failure, you realize that, well, that didn't quite work. And so, what do you do beyond that? So I think everything is based around, R&D, research and design, right? So it's, engineering is sort of this iterative process with everything that you do. So yeah, definitely.
That's great. So in my class, I have students do a group project, and I always tell them, I personally hate group projects, especially in class. You get to put together with people, and one person, they're going to do a lot of work. One person's sort of going to, sort of just get by, and you're got to talk with others, and you got to hear their ideas, and you've got to articulate your idea, and it's a lot of work. But yeah, that's the real world. Yeah. And I even hear you talk about, other people, Josh from Silka, Best Bike Splits, and Tom, and, these people that you surround yourself with. So how much of what you do is, a group project, if you will?
That's a really great question. I think that you think about what you do. If you're fortunate enough to love what you do, I fortunately have my own business, and so I kind of have the ability to pick who I work with, right? Like there's very few times where I used to work a desk job, and I would go in and I would be, and most of the people I worked with I like, but there's always somebody you work with, you're like, oh my gosh, why do I have to work with this person every day? And I think one of the things that I like is, I look at most relationships, if it's business or whatever, is they are relationships, and I think that you need to find people that allow you, that number one, they respect you in a way where they say there's a mutual respect, right? So if I'm working with somebody, we have an engineer that works for us, a guy, and he's brilliant. But there's a mutual respect there. I believe he trusts, he'd tell you different. I don't think he would, but he trusts what I do. I trust everything that he does. And so we both bring these different skill sets to the team. If I work with anybody that's not within the company, I've worked with people outside. You each kind of bring your own unique experience. And I think if you have that and you have that relationship, you can learn from people. Now, there are people out there that, quite honestly, I choose not to work with, because I think that they actually provide probably more of a problem than a benefit. If you're stuck in a situation where you're in a group project where you're with one of those people, I guess you kind of have to tell yourself, this too will pass, and how do you cope with that? To the best of your ability. You just got to believe in yourself. You got to you've got to, stay true to your values without being disrespectful, and realize that you're going to get some of the stuff you want, probably not some of the other things you want, but look at it as an opportunity to learn. Look at it as a way to realize what you do want in a partner in the future and what you don't. But take it as a blessing, I guess. Take it as a gift.
Oh, that's great. And yeah, I think that's the value of doing it in a classroom, is as long as, we as faculty, go over that with students, is, you do need to surround yourself with the right people. And
You
a
do.
good group project, you need to have the right perspectives. You got to have the respect for each other to talk, listen, and it forces, me to articulate my ideas better too.
And the truth is, I don't care what project you're working on. At some point, you're going to disagree on something, right?
No.
You're going to have an idea. And even if you work really, really well with somebody, I think that you get to this point where you say, you're just button heads, right? And I think the most important thing at that time is to say, okay, number one, what is the most important thing here? Number one, we want to make sure that we're going to maintain this relationship. We respect each other, and you need to hear each other's sides. You need to hear each other's perspectives. You need to understand, that there is a common theme, and you each have your own strengths. You each have your own weaknesses. You need to accept those of each other, and you need to say, the bigger point is we're going to move forward, and I think working with good groups and good teams allows those things to be possible. And I think, that's a good way to look at it. I mean, even in marriage, I'm a very happily married man. I have the most wonderful wife in the world, and every once in a while she thinks of something differently than I do, but we have just a great way to communicate and get through those issues. And that's what makes good teams, good relationships.
No, that's great. No, for sure. No, that's awesome. Well, let's see. We have been going for over an hour, and I could probably talk with you about cycling and all this and wheels, but let me. Where's Flo going? What's next on the horizon for Flo? I mean, you've built this company. You're 10 years deep into it.
Yeah.
It's amazing what you've built. Where are you headed?
We have the new product I was kind of mentioning, and I think, what was fascinating to me is that if you were asking me this question a month ago, I probably would have had a very clear answer, very specific. And today, unfortunately, we are looking at the most unprecedented event that I think any of us have ever experienced. We sell cycling wheels to people who race, and every race in the country has been canceled. So right now, as a company, we're asking ourselves the questions of how do we continue to sell a product? How do we get through a pandemic? And that is going to be a real challenge. Selling a retail sort of hobby type product, when you hit unemployment numbers of 6.6 million, is not necessarily a necessity product, And so you've really got to consider what that is. And so, we're still going to push as hard as we can to sell the new product and to figure out what we're going to do next. But like anything with business, you either adapt or you die, and I met this guy years ago. He founded a very famous cycling company called Felt. His name's Jim Felt, great guy. Talked to him a lot when we were starting. He said, a lot of times I describe myself as a firefighter. I walk around with a fire extinguisher on my back, and I go from one thing, I put out a fire, and then I go to the next, and put out another fire. And I think he was a good business manager. I don't think he was a bad business guy, but every once in a while you just have these unexpected things that pop up. And right now it's a thing called the coronavirus, COVID-19. So how do we adapt and how do we maintain? That's our big focus today.
Well, I've always been impressed with your company. I think you're founded on something other than just building wheels. And, like we talked about with your giving back to the community. And so I think it's really neat to hear you rethinking even just a vision and where your company fits in the bigger scheme of things. So, but I'm not surprised either. I mean, that's just what everyone knows your company to be and what you folks are about. So it's been,
thank you.
Yeah, it's been great.
I appreciate that.
Well, it has been. Ted, you got?
Yeah, I just got one thing to add to what Jon just said about the pandemic. And, the one thing I've noticed is that people are actually still riding their bikes.
Yeah.
And if not racing, they're still riding. And if I've noticed anything, actually, I think more people are riding. Some people actually have time. So maybe this will actually change the industry in a good way down the road. Maybe people aren't buying.
Yeah.
But more people are potentially out doing things. I think actually like gyms being closed, pools being closed,
Yeah.
bars being closed, restaurants being closed. You know, I rode my bike today and I was amazed at how many people I saw out riding bikes.
You rode out to the desert for this meeting, didn't you?
I did. That's exactly what I did. But I think that down the road, this, you know, there might be a bright spot for cycling.
Yeah, I hope so too. You know, I mean, I don't think cycling is something that people love, and it'll continue. And I think that we'll figure that out as we go. I think it'll be a great thing.
Absolutely.
Cool.
Once again, I'd like to thank you as well, and thank you for involving us in the project. It was awesome to work with you, and to, you know, I learned a ton.
Yeah.
I know John Mercer learned a ton. I know you learned a ton. So honestly, it was great to do that.
Awesome. Thank you. I appreciate it. You guys are great guys in my book. So I appreciate the time, and yeah.
Well, it's been fun. I am going to end the live stream, and I'm going to stop the recording. But if you just hold on for a second, that'd be great.
Sure.
All right. Thanks, John. Really appreciate it.
No problem.
All right. Live stream is stopped.